Hey everyone, welcome back to Education is Life, your go-to channel for unlocking the wonders of learning. I'm Joe Edgo, and today we're diving into Lesson 2 of our Arduino UNO R4 Minima Ultimate Training Series, focusing on the essentials of Arduino IDE and Arduino Programming Basics. If you missed Lesson 1, be sure to catch up because exciting things are in store for you today. Now, before we jump into the world of Arduino programming, I'd like to share why we embark on this journey. Our primary goal is to assist beginners in their Arduino adventure, and since this Arduino UNO R4 is new to the market, there is a noticeable gap in instructional videos specifically tailored for this board, and we're here to fill that void. Many beginners find themselves unsure of where to start, and we aim to be the guiding light, making this series a comprehensive resource for anyone taking their first steps into the exciting world of Arduino programming. Our hope is that this series truly becomes a helping hand for beginners, so thanks to the generous support of SunFounder, our sponsor, for making this journey possible. And this Arduino UNO R4 Minima Ultimate Sensor Kit is sponsored by SunFounder, will be our trusty companion throughout this course. Of course, you can have your preferred materials, but still, it is better for all of us to use identical components throughout this series. So, I encourage you to please check this one out. You'll find this on Amazon and on the official SunFounder website. The links are provided in the description below. So now, let's dive into the world of Arduino programming. Open up your Arduino IDE. If you haven't installed it yet, check out my previous video, lesson number 1, for a quick step-by-step guide. The Arduino IDE is an open source software which is used to write and upload code to the Arduino boards. Here, IDE stands for Integrated Development Environment. And ever since the Arduino was born, students, makers, and professionals have been using the classic Arduino IDE. And for today's lesson, we will be using the new Arduino IDE version 2, an improved version of the classic IDE with a slightly different user interface and has many new features such as auto-completion, a built-in debugger, and syncing sketches with Arduino Cloud. So, before we start writing codes, we'll first explore how to properly use this new IDE. The Arduino IDE version 2 features a new sidebar, making the most commonly used tools more accessible to us. On the top left, you will find the Verify and the Upload buttons. These are used to compile and upload your code to your Arduino board, just like what we did in the previous lesson. The Select Board and Port tool automatically shows detected Arduino boards here, along with the port number. The Sketchbook allows you to quickly find all your sketches locally stored on your computer, or you can sync with Arduino Cloud so you can obtain your sketches from Arduino's online environment. So basically, your Sketchbook is where your code files are stored. Arduino sketches are saved as .ino files and must be stored in a folder of the exact name. For example, a sketch named Arduino UNO _ test01.ino must be stored in a folder named Arduino UNO _ test01. The Boards Manager allows you to browse through Arduino and third-party packages that can be installed. Recall that this is the one that we used in the previous lesson to install our new Arduino R4 board. So, if we want to use another board such as the Arduino Nano ESP board, for example, this will require the Arduino ESP boards package to be installed. The Library Manager allows you to browse through thousands of Arduino libraries made by Arduino and its community. Libraries are extensions of the Arduino API or Application Programming Interface. And libraries make it easier for us programmers to, for example, control servo motors, read specific sensors, or use a Wi-Fi module without having to write a bunch of code from scratch. So, for example, if you want to use a temperature and humidity sensor in your project, you need to install an appropriate sensor library for your code to work. Now, another important part of the Arduino documentation is the example sketches that come bundled with libraries. Libraries that come bundled as part of a board package may also include example sketches. So, to open the example sketches bundled in either the libraries you have installed manually or that come bundled in core packages, navigate to File, Examples, and find the library you are searching for in the list that appears. In here, you can see a bunch of examples. We have built-in examples, we have examples for Arduino UNO R4 Minima, and you should see these examples after you have successfully installed the board package, as we did in Lesson 01 of this course. So let's try this servo sweep example. And here is the example code with a brief description of how it works. So, browsing through these examples is actually a great way to learn Arduino programming. Now, the debugger allows you to test and debug programs in real time. It can be used to navigate through your program's execution in a controlled manner so that you can find and fix errors in your codes. You'll learn how to use this properly when we start writing codes. Then you have the search tool. This allows you to search for keywords in your code. For example, the word setup exists twice in your entire program. The serial monitor is a tool that allows you to view data streaming from your board, like for example, the serial.print command. Now, with this new IDE, the serial monitor tool is displayed as a new tab in the console integrated within the editor. Compared to the classic IDE, this tool has been located in a separate window. Well, the idea is to make it easy for us to have multiple instances of this serial monitor running at the same time on your computer. And there is also this serial plotter tool, which is a great tool for visualizing data using graphs. We'll use this one as well in some of our future lessons. Now, when writing a program, the auto-completion feature is a must-have for code editors. And the Arduino IDE version 2 comes equipped with this tool. Not only that it saves you time typing, but it also gives you an understanding of how the programming language works. So, to enable or disable the auto-completion feature of your IDE, go to the File, Preferences, and then locate this Editor Quick Suggestion checkbox. Check this one and click OK. So, why would you need this auto-completion feature in the first place? Well, whether you're writing in C++, Java, or any programming language, understanding the syntax and how to write code to call certain functions is very important. So, this auto-completion tool, when used correctly, should increase your knowledge of Arduino programming while allowing you to write code faster. For example, if I type pin, the auto-completion tool shows me all the possible commands that I could type that start with the word pin. I could continue typing if I know exactly what function I want to execute, or simply select the function that I want to call using the mouse or arrow keys. And then, hitting the tab or the enter key should autocomplete the code for me. In this case, the function we selected happens to have two parameters: the pin number that we want to configure and the mode of the pin. This automatically gives us a guide on what data we are supposed to place in this area of our code. So, to pass values to these parameters, simply type the desired pin number for the first parameter and then press tab. It automatically proceeds to the second parameter, and I'll type pinMode of output and press the tab again. And then end this line with a semicolon. Now, as you can see, if you're not that confident in writing codes yet, the auto-completion tool can be a real time saver, and it helps you develop an understanding of the Arduino language. However, if you prefer typing codes on your own without any auto-completion assistance, you can simply ignore this one. So now, let's start learning how to write our own Arduino codes. Notice that whenever you open a new sketch in your Arduino IDE, you immediately get this void setup and void loop code blocks written for you. Well, these two are called functions, and these two functions are mandatory in Arduino programming. Notice that I can compile this sketch having only these two empty functions and it should compile just fine. Now, if I try to compile a code with one of these functions missing, then I'll get an error. Also, I mentioned in our previous lesson that the Arduino programming language is a variant of C and C++ programming languages. Well, basically, the Arduino language is a framework built on top of C++. The main difference though from the normal C or C++ is that you wrap all your codes into these two main functions. You can have more than two functions, of course, but we'll talk more about that in some future lessons. Now, this setup function is called or executed once when the program starts. That's why you see a sample comment here denoted by these // symbols that says, put your setup code here to run once. So, typically, this is the place where we should write all our code initialization and configuration. However, this loop function is repeatedly called or executed while your program is running. So basically, most of your codes like interacting with the LEDs, motors, and sensors will go here. Now, if you have previous knowledge in C or C++, you will notice that we don't have a main function here as the entry point of our program when executed from an operating system. It is because Arduino boards are single board microcontrollers or SBMCs with firmware rather than an operating system. Well, a firmware is just a piece of program installed on a hardware device like this Arduino board we're using. It doesn't have an operating system similar to your Windows or Linux, for example. But we can write programs using this Arduino IDE at a higher level to upload or burn firmware to the Arduino's flash memory. So now, to correctly write an Arduino program, you need to know this set of rules that determine the correct structure of this programming language. And this is what we know as syntax. Syntax means the rules that control the structure of the symbols, punctuations, and words of a programming language. And if we don't follow the syntax of the Arduino language, the code will not be understood by the compiler. So for example, if I give you this sentence, Brown jumps the lazy over dog, fox quick the period, this doesn't make sense or has very little meaning to it. This meaning is what we call semantics of the language. So if I apply the basic syntax for the English language, I could rewrite this as the quick brown fox jumps over the lazy dog, period. This sentence can now be understood. So for beginners, we need to know the rules of this Arduino language because without following these rules, it is impossible for us to write a functioning code. We will be getting a lot of this, what we call syntax error. So first, we need to know naming conventions. Naming conventions are a primary component of basic syntax conventions and this varies by language. Arduino language, the same as C, is a case-sensitive programming language. As you can see here, if I change this lowercase v in void, making it uppercase, it can no longer be recognized by the compiler, producing a compilation error saying, void does not name a type. Now, a function name is always followed by a pair of parentheses. Then followed by a left curly bracket. This is to indicate a start of a program or a code block. And then a right curly bracket to indicate the end. If you missed one, you'll receive another compilation error. Now, in most Arduino tutorials, your first Arduino program will surely involve making an LED turn on and turn off. And to do so, you will need to use several functions along with some constants. Well, part of the Arduino programming language is the built-in libraries that allow you to easily integrate with these functionalities provided by the Arduino board. So for example, to write a program that turns on the built-in LED connected to pin 13 of our board, first, we need to configure pin 13 to behave as an output pin. And to do so, we can call the pinMode function and watch out for the correct casing here. And then I'll specify the pin number and a constant output to denote that pin 13 is to be configured as digital output pin. By convention, constants are written in uppercase letters. Well, in C language, all statements must end with a semicolon, just like putting a period at the end of every sentence. So now, placing this code in the setup function means that this code will run only once. And so to actually turn it on, I will call another built-in function, digitalWrite. And this function also requires two parameters, the pin number and the pin status. So I'll pass in pin 13 and I'll use another constant here, high, which is synonymous with on, and then end with a semicolon. Now, make sure that your device is connected and properly selected here, and then you can click upload. And we can see pin 13, the one connected to the built-in LED, turns on. So if we want to turn it off, we can simply change this constant value from high to low. Let's upload it again and it's good. The built-in LED turns off. Now, what about this loop function? Well, if we want a code that gets executed repeatedly, we should place it here. For example, to produce a blinking effect on this built-in LED at pin 13, we need to alternately turn it on and off at a certain interval continuously. So, I'll move this code down here and then duplicate it, and then I'll change this first line of code to high, so it should be able to perform on, off, and then loop, on, off, and then loop repeatedly. Let's try uploading our code. And okay, it's now blinking. Well, it's actually blinking, it's just that you cannot perceive it because it's very fast. Well, we'll get into the technical details of how fast this microcontroller can execute a code in some future lessons, but for now, you just need to know that it is working, but it is blinking faster than your eyes can perceive. So, if you want to see it blinking, we can use another built-in function called delay and insert it in between these codes. So, the delay function requires one parameter, the amount of time the process is to be put on hold, and this is in terms of milliseconds. So, if you put 1000 milliseconds, it is equal to 1 second. Now, I'll put another delay here so that it pauses for 1 second before it loops back, so that we can see the LED turned off. Okay, let's test it again. And if you notice, this is exactly the same example sketch that we uploaded from our previous lesson. The only difference is that instead of specifying pin 13, the example sketch uses the LED built-in constant, which basically mean the same thing. Now, in addition to this constant LED built-in, which points to this built-in LED connected to pin 13, there are two more onboard LEDs on your Arduino UNO R4 that you can program. These are the receive and transmit LEDs. So in your code, you can access these onboard LEDs using the constant LED_RX and LED_TX. So if I want to make this receive LED blink instead of this LED built-in in pin 13, I'll simply change this to the constant LED_RX. Okay, let's upload this new sketch. And here you go. The receive LED is now blinking. Now let's have another example. Aside from this LED_RX, let's include this LED_TX and make them blink alternately. What I mean is, when LED_RX is on, the LED_TX should be off. And when the LED_RX is off, the LED_TX is on. So, I'll duplicate this code and change this constant to LED_TX. Also, I'll duplicate this digitalWrite code and change this constant to LED_TX as well, but the value is low. Now, I'll copy this code and paste it here, and then change the value from low to high. So our logic seems okay, and all we must do is upload it to see if it works. And it works perfectly. Now, before we end this lesson, I want to give you a programming challenge so that you can practice what you've learned. Try to imitate this output wherein the LED_TX turns on, followed by LED_RX so that both LEDs are on. Then, LED_TX turns off, followed by LED_RX so that both LEDs are off. And then, the process repeats. And congratulations! You now understand the fundamentals of Arduino programming in addition to the ins and outs of the new Arduino IDE. For our succeeding lessons, we will continue learning the various Arduino programming constructs as you learn how to build circuits and how to properly connect your components to the breadboard. If you found this lesson enlightening, don't forget to hit that like button, subscribe for more knowledge-packed sessions, and ring the bell to stay updated. So, keep learning, keep experimenting, because remember, education is life. See you in our next lesson. Happy coding!